This is the video lesson I created using EDpuzzle. Today you will be completing a video lesson on how to find the missing side of a similar shape. Watch the video and answer the quiz questions as they are presented. The quiz questions will then be sent to Mrs. Williams for grading.
How to find the missing side of a similar shape. Well, let's review a little bit. What are similar polygons or similar shapes? Similar polygons, they have the same shape, but they're different in size. So here's three examples of shapes. They have the same shape, but they're different sizes. Now, one thing that's really important is that the sides are proportional on similar polygons. Well, what does that mean, the sides are proportional? Well, it means they have the same ratio. So here we have three similar right triangles. They all have the same shape, and they are similar. And the way that we know that they're similar, if you look at their sides, the smallest one has a ratio of 3 to 4 when you're comparing these two sides. The ratio of the middle size right triangle is 6 to 8. Well, that simplifies to 3 to 4. It has the same ratio as the first triangle, and the largest right triangle has the same ratio as the first two. It's 12 to 16, and 12 to 16 simplifies to 3 to 4. So that's how we know that these three right triangles are similar. Now, here are two right triangles. Are they similar? Do they have the same ratio when you're looking at their sides? This one has a ratio of 6 to 18, which would be 1 to 3, would simplify to 1 to 3. The larger right triangle has a ratio of 12 to 16, which is 3 to 4 if you simplify it. They don't have the same ratio. Those are not similar triangles.
The correct answer to the first question is no. Students would answer no to this question and then hit continue the lesson.
So we can use proportions to figure out missing sides of similar triangles. It's real easy to do. So in this first example, the ratio of this triangle is 4 to 6, and it's equal to the ratio of the second triangle, which is x to 15. Now we can solve that a couple of different ways. We can either use equivalent fractions or cross multiply. I'll cross multiply on this one. So 6 times x is 6x. 4 times 15 is 60. Now we have a nice easy one-step equation. So our missing side would be 10 meters.
The answer to this second question is 75 feet. You then hit click continue.
If we look at the next example, the ratio of this triangle is 40 to 45, and it has the same ratio as a triangle that's similar to it, 16 to x. Now, rather than cross multiply on this one, I think I'm going to use equivalent fractions. Now remember, on a proportion, you can simplify a fraction. So if I divide each of these by 5, I would get 8/9. And that makes it real easy to solve. 8 times what is 16? 8 times 2. So I do 9 times 2. That means our missing side would be 18 centimeters.
The answer to this question is 7 meters. In the remainder of the examples, he uses equivalent fractions to solve for the missing side length. You may use a proportion and cross multiplication or equivalent fractions, whichever you prefer.
Okay. Now this is pretty important. Remember, in the first couple examples I just did, I only labeled two sides. If all three sides are labeled, make sure you're comparing the same two sides. And you're not comparing, for example, using this number, and then this side and this side. That wouldn't be accurate.
The answer to this question would be 4 corresponds to 5, 8 corresponds to 10, and 6 corresponds to 7.5.
Okay, let's try a few more. So, the ratio of this larger triangle is 32 to 20. and the ratio of this triangle is 24 to x. Now I could cross multiply, but I think it'd be easier to see if we can use equivalent fractions on this one. Now if I simplify this and I see that 4 goes into each, 4 goes into there 8, 4 goes in here 5, I could use equivalent fractions. 8 times 3 is 24, 5 times 3 is 15. Our missing side right here would be 15 meters. Okay, another example. Well, the ratio of this triangle is 14 to 22. The ratio of this triangle is 35 to x. Again, I could cross multiply, but I'm going to see if I can use equivalent fractions. If I simplify this, and they're both even numbers, 2 goes in there 7, 2 goes in there 11, I notice that I could use equivalent fractions. 7 times 5 is 35, 11 times 5 is 55. Our missing side would be 55.
The answer to the last question is x equals 6 and y equals 24.
Centimeters.
Tomorrow in class, you will be using this concept to find the height of tall objects using similar triangles.